All right, guys, for this problem, it says find where the function f of x is equal to 3x to the fourth minus 4x cubed minus 12x squared plus 5 is increasing and where it's decreasing. Well, in order to find those intervals, the first thing I got to do is find my critical numbers. In order to do that, I have to find the derivative. So, as always, when in doubt, take the derivative. So, the derivative of my function would be 12x cubed minus 12x squared minus 24x. Now, I notice that this is a polynomial, and a polynomial is continuous and differentiable on its entire interval, so don't have to worry about where the derivative is undefined, but I do need to know where the derivative is 0, because that would help me find my critical numbers. Well, by setting this equal to 0, I notice that there is a GCF that I can pull out. I can actually pull out a 12x, and that'll leave x squared minus x minus 2. And then I notice that this is an easy trinomial, thank goodness. So factors of negative 2, that would give me a negative 1. That would have to be negative 2 and positive 1. So I'm just going to factor that out. And so I'm left with this fully factored. And so I'm going to set each one of them equal to 0. So I get my critical numbers of 0, 2, and negative 1. Okay? Now, once you've gotten those critical numbers, what I'm going to do is I'm going to make a sign chart. And on this sign chart, I'm going to put my critical numbers in order. So negative 1 is first, then 0, and then 2. All right, here's what I'm going to do. I'm going to pick a number between each interval, and I'm going to test it in the derivative and see what my sign is. So check this out. Pick a number that's less than negative 1. So let's say negative 3. All right, well, if I choose negative 3, a positive 12 times a negative, this is going to be a negative value, correct? And then a negative 3 minus 2, that's going to be a negative value. And then a negative 3 plus 1, that's going to be a negative value. So a negative times a negative times a negative, that's going to be a negative. So that means the value of the derivative on this interval from negative infinity to negative 1 is negative. All right, now let's pick a number between negative 1 and 0. Let's try negative 1/2. Well, 12 times a negative 1/2 is still going to be negative. A negative 1/2 minus 2 is still going to be a negative. But a negative 1/2 plus 1 is going to be a positive. So I have a negative times a positive. That's going to be a positive, so that means the derivative is positive between negative 1 and 0. All right, next interval, between 0 and 2. Ooh, let's pick 1. That's an easy number. So plug in 1 into the derivative. 12 times 1 is positive. 1 minus 2 is a negative. 1 plus 1 is a positive. Positive times a positive is a negative. So the derivative is negative on this interval. And let's pick one more number. Let's pick a number bigger than 2. Let's pick 5. 5 times 12 is a positive. 5 minus 2 is a positive. 5 plus 1 is a positive. Positive times a positive times a positive is a positive. So all those are positives. All right, so now that you've got your sign chart, we can figure out where the graph is increasing and decreasing. Because remember, wherever the derivative is negative, the graph is decreasing. Wherever the derivative is positive, it's increasing. So where is the graph increasing? It's increasing where the derivative is positive, so it'll be on the interval negative 1 to 0 and 2 to infinity. Now, you don't have to write it like that. You could write it as x is between 0 and negative 1 and x is greater than or equal to 2. So that would be where it's increasing. Where is the graph decreasing? Well, that will be where the derivative is negative, which in this case would be from negative infinity to negative 1 and from 0 to 2. And then if you don't want to write it in that notation, you can write this as x is less than or equal to negative 1 and x is between 2 and 0. But either way, those would be my intervals for where this function is increasing and decreasing. And you could actually graph the original function into your graphing calculator and just double check that those values are correct.